Zoom. We're getting all of this done. How's homework going, folks? Because I haven't got a lot of questions from people, and it doesn't look like there's a lot of people who finished it. So somewhere in the middle is where we are, I think. So anyone want to ask questions in this moment in time? It's due tomorrow night. Terry, please ask me a question.
Okay. So could you go back over one more time how the pieces fit together with the logic slope, the odds ratio, and the probability?
Yes.
Because essentially what I'm getting confused, I just want to double check with my interpretation is like, is that it's like 0 to 1 and then 1 to infinity, correct? And yeah, so I just get a little bit confused.
Okay. So I'm on slide 12 of lecture 1 to help answer this question. So the three metrics, you have logits, a logit of 0 corresponds to a probability of 0.5. And odds of 1 corresponds to a probability of 0.5. Logit coefficients are symmetric. So like if you have a logit of -3 for the probability of a 1, you know that the logit for the probability of a 0 is 3. Let me see, here, let me.
Do it again, please.
Yep, sorry. We're pulling out Excel. Excel is great for demos, not so great for modeling. But it's thinking about it. Yeah, it heard me talking shit about it. It's like, I'm not going to open it. Okay. I know. Okay. So let's do this. And I have something like this actually in your example 1, but I'll just do it from scratch here. So if I have a probability, I go to odds, I go to logits. Okay? Do you remember the formula? How do I get odds? How do I go from probability to odds? Yeah. Not yet.
Okay.
Not yet. So I'm going, this is the link. I'm going from the conditional mean, which is probability, up to logits. So it's the probability of, hang on. Let me back this up here. Probability of 1. Make this specific. I'm going to insert a new column here. This is a probability of 0 instead, okay, which is 1 minus the probability of a 1, right? I only need to know one of these things. Odds is the probability of a 1. Here. I'm going to insert the formulas as words so that we can keep track of that. Equals 1 minus prob of 1. Okay? Hey, no! I know, it's like, you can't do that. All right. Odds is probability of 1. I'm shortening this, okay? Over probability of 0. Right? With me? So let's put that number in here. That one over that one. Odds of 1. 50-50. Logits is if you take the log, which in Excel is ln, not log, as I recall, the log of odds. So it's ln times that thing. And what number is going to show up? 0. So if I have a probability of 0.5, that's sort of like my null hypothesis, right? Just as likely. No effect kind of thing. If this goes to 0.8, that translates into an odds of 4 and a logit of 1.3. Let me do another line here. If I swap this, okay? If the probability is above 1, no, then you don't have an answer, because that can't happen. Then you're using R, and someone messed up the program. No, that happened for real. My husband used an R package in a workshop once where it returned a probability of 1.2. So let me try this again. I'm going to refuel for a moment. If I have a probability above 0.5, that translates into some kind of odds above 1. What's the highest an odds can be? Where does it stop? Infinity, positive infinity. A logit, if you take the log of the odds, is 1.3. Now note the symmetry here. The logit that goes with the probability of 0.8 is exactly the opposite of the logit that goes with the probability of 0.2. That's what I mean when I say logits are symmetric. But look at what happens to odds ratios. Everything that corresponds to, not odds ratios, odds. Odds is a ratio. I got to stop saying that. Just odds. Odds that go with probabilities between 0 and 0.5 are all compressed between 0 and 1. The lowest that odds can be is 0. So if I make this even more extreme, like that. So that's how you get from one to the other. Now, how do you go backwards? Let's say that I have this number right here. Paste the value. So if I'm given logits, how do I go backwards? How do I go back to odds? E to the logit. Right? That thing. Now, how do I go back to probability? I always skip over odds in my head. It's e to the logit over 1 plus e to the logit. That. Let me make this bigger. Equals e to the logit over parentheses 1 plus e to the logit double parenthesis. Is that right? Yep. I put it in the wrong column. It goes over there. So to go from probabilities to logits is link. To go back down from logits to probabilities is inverse link, or I-link in the programs. So if this logit reflects a predicted outcome, like what is the logit of getting a job if you have 2 papers and 5 publications and blah, 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 right? If this is a predicted outcome, you can express it in logits, you can translate it back down into odds, and you can translate it back down into probabilities. Cool. If this logit is a slope, like for every additional paper, your logit of getting a job goes up by 2, if that's what it means, you can exponentiate it down to odds, but you have to stop there. You cannot inverse link a slope, because a 1 unit change in logits does not correspond to a constant unit change in probabilities. There is a picture that I like for this earlier in this same lecture. This one, this is slide 8. Logits are on the bottom, and the lines going up above are the probabilities they map onto. So the same unit change in logit is a different amount of change in probability depending on where you are on the probability scale. Because the effect of a variable has to shut off in order for it to not exceed 1 or 0. So that one of the articles I posted, I think like 2 weeks ago, had some examples of this, because when you're dealing with this type of curve, right, if you want to talk about what is the effect of going from an x of 10 to 11, that's a less effect than going from an x of 5 to 6. in this case. It has to be. And so what the effect is in probability depends on where you are in probability. So you cannot unlogit a slope all the way down to probability. The only thing you can do is exponentiate it and talk about an odds ratio. Okay, does that help?
It does. Okay, so then the next step of interpreting what that means. So I think we have the odds, I go back and look at the logit and whether it's a negative or positive to tell me if it's more likely or less likely.
Yes.
That's the right way to, okay.
Yes, that works.
Okay, that still works. All right. I'm like, I'm going to go back here and I think this is right.
Yeah, these odds ratios, if they're odds ratios, people talk about them as percent change. Like an odds ratio of 9 is like 900% change. But to talk about the same absolute effect size in the opposite direction, it's like only a 12% change. Like I hate the asymmetry of it. I just can't handle it. But I accept that the world wants odds ratios and you can ask for them very easily. So in SAS, you can add EXP to any estimate statement to get an odds ratio, or you can add ILink to get a predicted probability. In Stata, predicted probabilities are available in margins as the default. Predicted logits are available if you add predict XP. And on lincom statements, you can add comma OR and get odds ratios. Thank you for that tidbit. So yes, there shouldn't be any of this that you have to calculate in Excel. You should be able to get it from the program. Now, there are several answers in the homework where you could probably do it by hand, right? Like you could find the difference in logits between two numbers that you already found, right? But if you do it by hand, even though you get the difference, what don't you get? Standard error and the p-value that goes with it. So it can be helpful. Let's see, looking at section 3, for instance. Simple slopes are available as lincoms or estimate statements. Differences in simple slopes are also available as lincoms or estimate statements. You can manually calculate the difference, and then you know your lincom statement worked. Like if you're outside the homework system where you don't have red and green boxes, like you're in life, figuring out what it should be using your calculator or Excel and then making the program do it is a good way to know that you did it the right way. Technically speaking, you probably could calculate standard errors in certain situations, but not in these models. They are byproducts of the likelihood estimation process. They're related to the second derivative of the likelihood function for each parameter. That is beyond my pay grade in math. Okay, other questions? I had folks ask me before everyone got here about these ones, the difference in slopes. It is not a coincidence that I ask you for the slopes first and then the differences. Because if you know how to get each of these slopes, you know how to get the differences. You can literally take the lincom statement for each slope and subtract the lincom statement for the other slope, see which terms cancel and what values are there for things that get left. So I can help you with that or give you an example of that if it's helpful. Other questions? Yeah, more? Bring it.
I just want to make sure. So I've got my odds ratios. When the odds ratio estimates, when you run that, you don't get any p-value associated with it. So going back to the logit slope. Okay, cool.
Yep.
So make sure that I'm going backwards correctly.
Yeah, the p-value for the logit has to be the same as for the odds.
Perfect.
They're just on different scales.
Awesome. Thank you so much.
Logits range from negative infinity to positive infinity, and they are symmetric corresponding to the probability of a 1 versus a 0. Odds range from 0 to 1 if it's a negative number, basically, and it goes from 1 to positive infinity if it's a positive number. Yeah?
So, is the n term or n whatever supposed to be for odd ratios?
N-lincom is if you want to do a nonlinear combination of parameters, such as if you want to do an e to the exponentiate something by hand.
You solve that by just adding.
Correct. The one instance in which I couldn't figure out how to do it is if you have an empty model, because there's nothing to margin over. And in my example, I added an NLCom just in that one instance to try to do the inverse link from the logit down to the probability. This version of the formula, by the way, is the shorter version to go inverse link.
So is that just like memorizing?
Yes.
Okay.
You have to have the formula to know how to tell it to do it in that case. So it's annoying if it's like something that is complicated, but it also gives you the freedom to make up new things. Where is, I'm looking for the formulas, this slide. So these are how you go from one to the other. Note the two different versions of probability for the inverse link. If it's e to the logit over 1 plus e to the logit, that's the one that I have in my head. If I'm programming something and I want to avoid typing, it's 1 over e to the minus 1 times the logit. These are mathematically equivalent. One is less typing. So the version of this that I have in Lincom is the bottom one. It's 1 over 1 plus e to the not logit, minus 1 times the predicted. Other questions? Questions about interaction terms, simple slopes? Is any of that throwing you for a loop? I got an email from one of you who was concerned that they figured out the right answers with code that didn't look like mine. Who was that? Is that person here? Yeah, that was you? You're still right. These programs have an infinite number of possible ways to get the same piece of information. If you figured out a way to get it, you are right. I'm giving you like some limited set of examples to draw from, but in practice you may have to modify and change. Part of the difficulty is that not all routines have all options. So like you can't have the certain kinds of margins and certain kinds of things, or certain kinds of lincoms or estimates, or like you have to figure out sort of which procs or routines allow certain options and learn how to work around it. For instance, we were just talking the class state of people. You can get simple slopes via margins for a command called dydx. I haven't shown you that because it sort of hides the logic by which you compute the simple slopes, and I want you to understand that logic, but it is once you're good at it and you're tired of typing, that's one way to get it faster. dydx. Other questions? Okay, so homework due tomorrow night. Let me know if anything else comes up. Your next homework is likely to be due, I'm moving it from Monday to Wednesday, so it'll be 2 weeks from now. I haven't decided what I want you to do for your next homework, to be honest. I was thinking it was going to be counts, but we're like 2 days behind schedule, and so I don't want to like get off cycle in terms of the number of formative assessments versus those. Do you feel like doing a ordinal assignment? Would that be helpful? You like want to practice some of those for the second one? Ordinal and nominal? Go logit. Go logit. Yeah? Okay, I'll make up something like that. I need a new story, though. I don't have an ordinal example in my repertoire, so I have to come up with a new story. That'll be my challenge for tomorrow. Each of these homeworks takes somewhere between like 4 and 20 hours to build, depending on the level of complexity of the model and the number of questions. So it's non-trivial, but I'm happy to do it because then I get to ask you to do more complicated things than if I were having to hand grade all of your work, right? Okay, so we'll shut that down. Where were we last time? We were talking about logits and nominals and stuff like that, right? Remember that? Are we ready to change gears and do that? Are you ready? Yeah, take a breath, center. Have a drink, whatever beverage of choice. Let's review. Too logit to quit. So in terms of types of regression, different software packages and different people name these inconsistently. So you can't always be sure what something is doing until you look under the hood and see exactly what kind of link it's doing and what kind of distribution it's doing. So this is why I'm trying to be very specific in how I describe things and not rely on names because people have different naming conventions. So what we're talking about is transitioning from an outcome that only has 2 categories to an outcome that has more than 2 categories. And your choice as the analyst is to decide how those categories relate to each other. Are they ordered or not? There is a condition of partially ordered, but honestly that has dropped out of software and I never see it used. So the middle one is pretty much gone. So ordered or not are your 2 main sets of choices. I had an interesting discussion this morning, let's see, about which regression is better, a linear regression or a logistic regression or a multinomial regression. What do you think? Is there a preference for one versus the other? Like in absolute sense? No. How do you know which kind you need?
Based on what you're doing?
Based on what I'm doing, a little more specific. You're not wrong, but that's also pretty vague. Outcome, yeah. What kind of outcome do you have? Now, what kind of outcome should you have? That's a whole separate other discussion, right? When you're designing a study and you get to make those choices, whether to ask a question using ordinal responses versus asking for exact information, there's a whole field of literature on that known as survey research methodology, how to design good questions and good answers. For something like, how much money do you make a year, right? The easiest way to ask that is literally have that question and have them enter a number. For various reasons, that's typically not what people do. They either don't want people to have to disclose that level of specificity, that intrusiveness, and they say like under 10,000, 10 to 20, 20 to 30, something like that, or they don't believe people. So like if I asked you, Terry, in the last decade, how many times have you eaten chocolate?
1,000.
You're just pulling numbers out of the air, right? Like some people could say never because they hate chocolate. For them, that would be an accurate number. But for the rest of us, we're terrible at estimating rates of things, right? For open-ended questions like that. And so to make a variable that might be more reliable, we might have choices like never, a couple times, once a week, once a month, something like that. So whether or not you want to measure something quantitatively or categorically is a separate set of decisions. I'm just assuming that for better or worse, this is what you're stuck with. You have a categorical outcome, but you want to predict it, picking the right model to go with the type of outcome. All of the models we're talking about assume independent observations so far. If you don't have independent observations, if you have dependency, then you need a different kind of model. But in that case, it's a more complicated model that involves this stuff as a baseline. You have to add stuff to it in that case, but all of these things still work in terms of what to do with this type of outcome. So if you have a binary outcome, what kind of distribution will you use? There's only one answer. Bernoulli, that's it. It can't be wrong. That's the only one. What kind of link would you use with a binary outcome? What are the choices that we talked about? Logit, that's most common. Rhymes with logit? Probit. The one that is like 2 words? Log. 3 words? Complementary log. There's probably other ones out there, but what they do is different ways of taking what is a bounded outcome, probability bounded between 0 and 1 is the conditional mean, and stretching it into something that is unbounded. So logits is one way of doing it. Probits is a z-score. Same idea of unbounded, centered at 0. The other ones have asymmetry built in. So you have different choices for what kind of link. The same is true when you have more than 2 categories. There is only one distribution, and it's multinomial. Multinomial is the probability of each category, except for 1, because once you know like 2 out of the 3, you can figure out the third because they have to sum to 1. That's it. So there's no choice to be made there. It's multinomial. The logit. So in addition to having the dimension of logit versus probit versus log, then you have how do we arrange the categories relative to each other as another dimension? Are they cumulative or are they like one versus the next? Generalized or baseline category. If you think of your outcome as something that is ordered and you're interested in sort of this idea of a threshold, right? Like in the example of income, where it's like in brackets of 10,000 or something like that. Like if you want to predict sort of the logit of making more money, like that's what you're interested in, then an ordinal type of model, cumulative logit, cumulative probit, cumulative log, that kind of thing maps onto that idea. If you have categories that are ordinal, but you're not thinking of them that way. So like in our example, there's 3 choices about whether or not you're going to apply, there's 3 choices for whether or not. I'm on a roll today, I gotta tell you. I need a refill here. There are 3 choices with respect to applying to graduate school. There's no, yes, and maybe. If you are doing a study on this phenomenon, trying to predict when people are more likely to say maybe than no, like that's one kind of person, right? Like there's like no, definitely not, and eh. The factors that separate the eh people from the no people, that's one type of thing. It's a different set of considerations to go from eh up to yes. What predicts your probability of transitioning off the fence in a positive direction? So even though inarguably no, maybe, yes are ordered, you may be better off with a model that's generalized where you're comparing one category to another one so that you can answer questions more specifically about why somebody would pick one category versus another. The same would be true if one of your categories is refused to answer. So there are models for latent variables that I've come across recently for that the same logic holds. If you have, what's your favorite kind of pet? Dog, cat, bird, I'm not going to tell you, right? I'm not going to tell you is a valid answer. You can predict why someone would say, I'm not going to tell you versus each of the others. You could do the same thing for income. So it depends on the kind of data and it depends on what you want to know. Now what you can't do is say, favorite kind of pet, dog, bird, or cat, and say that's ordered. The correct order, of course, is cat is best, and then bird, and then dog, right? We all agree on that? And therein lies the problem. So that's the one thing you can do to screw this up, right? Use an ordered model on data that are not ordered. Otherwise, it's your choice, and it depends entirely on what you want to know. So I think staring at you, remembering your question, forgetting your name, Kelly, damn it. I was talking about this last time, right? In terms of your example. Do you want to tell us about that again real quick?
Is it always true?
Yeah.
Question? So I have a couple of questions that are like not true, sometimes true, always true. And they're like, is there a difference between not true and then true at all? Or
Mm-hmm.
what are the questions?
Yeah, not true versus true to some extent.
Yeah.
That idea is directly captured with this cumulative logit. If you wanted to know what is not true versus a little, not true versus a lot, not true versus very, that idea is directly captured by generalized logit. So it depends on what you want to know. This latter category of generalized logit is also known as baseline category logit. There may be others, but this is the one that Stata calls multinomial. And other people do too, even though all 3 of these models use the multinomial distribution. So it's not multinomial regression is not a good name. It's too generic because it doesn't tell you what your ordering system is in here. So if you're going to describe an analysis, I would say what the distribution is and what the link is. And probably it wouldn't be a bad idea if you're in a field that doesn't use this much to explain how the model works. Okay. Good so far? So what's the difference between these? It's how the submodels are created. So both ordered categories and unordered categories rely on partitioning the data into submodels that are binary. It's how they're partitioned that differs. So in ordinal models, this is cumulative logit or cumulative probit, cumulative something. All of the answers get used in every submodel. That's helpful in terms of coming up with more stable estimates. This is known as proportional odds modeling. that is the name of a model that is actually another bad name because that's an assumption of the model, but you can change the model if you don't like that assumption or if it's violated. IRT people, what's this called? You can read it from the slide. This is the graded response model. So when you hear about that, incidentally, I took IRT from Susan Ebertson before I had any of this material. I had no idea what a logit was. And so I learned all of this stuff in the context of latent variable modeling. And all of it was new at the same time. And then as a postdoc, I sat in a class on these models and I was like, holy shit, that's what she was doing. Like, it's so much harder when you have to understand all of this link stuff in the context of latent variables too. But once you get this for observed data, if you stick with me in the fall to take structural equation modeling, we'll do those models in the context of that, adding latent variables to the mix. So stay tuned for that. But the cumulative model divides the categories into submodels where it's either going to predict the red or the green. So each of these is still binary, and you know exactly what to do with it. It's the logit of the higher category, if your model is phrased in the green way, which is what I always do, or it's predicting the logit of the lower category if your model is phrased the other way. To get the probability of any one response, you have to subtract between the predicted probabilities of these submodels. We talked about proportional odds. That's the idea that no matter which submodel you're in, the slopes are the same. That's a testable assumption, although it's tricky to do so. That's where GoLogit came in. And then the other one that we haven't seen the example for yet, baseline category, it's like dummy coding your outcome. One of your outcome categories is the reference for the model, that's like the 0. And then you have a submodel comparing each other outcome to that one. So it's not cumulative. It's, I want to say conditional, but that's not a very specific word. Like, each of these submodels, there's a word and I can't come up with it. God, I'm doing bad today. Conditions, that's the word I want. Conditions on the two answers. So like submodel 1 here, 0 versus 1, it's like, given that your answer was either 0 or 1, what's the probability that it was 1? And then given that it was either 0 or 2. So it's like it discards the other people from that submodel. Whereas cumulative logit uses everybody in each. Yeah.
So why would you want to do that last one?
Dog, bird, cat. I had an analysis that I did on a follow-up to my dissertation. My dissertation was actually about predicting automobile risk in older adults, believe it or not. I used to care about that kind of stuff. And I had a driving simulator, and I had performance in that as an outcome, and I had their accident records that they consented to give me permission, and I was trying to predict real-world accidents. I did a follow-up study 5 years later where we called them up and said, oh, by the way, remember that study you were in? Have you crashed your car into anything since then? And the answers were, yeah, no, what are you talking about? Or this person is dead and unavailable to respond. Or we couldn't find them, right? Hard to know where dead goes, right? Like if you think about a continuum of ability, crashed your car is worse. Alive is, but crashed it, like not crashed, right, and then dead. But it's weird to think of that as ordinal. And so, like, if I have sort of not crashed versus dead and then not crashed versus crashed is the way that I set it up. So I think there's a lot of situations in terms of non-response and that kind of thing where this type of modeling could be useful. It's just important to recognize the conditioning. It's like it subsets the world to just, if it's one of these two, then what happened? It's not that different than literally just carving up your data and doing a logistic regression on just that. That's the easy way to do it. But you know what you don't get to do if you do that? You don't get to test whether or not a predictor has the same effect in predicting 2 instead of 0 as it does 1 instead of 0. So a simultaneous modeling is how you can make comparisons across the submodels. But the open in case of emergency option is to literally separate them yourself. Okay. We talked about that. Yeah, so we got all the way through the lecture. How about that? We haven't done all the examples yet. let's go to, this is example 1 still, week 4 of the class. Okay, this is still binary. Binary, binary. This is what we were looking at last time, ordinal. Do you want to go back over ordinal before we jump into nominal, or do you feel good about this? It wouldn't hurt. The worst that could happen is that you remember this and feel good about yourself for following along, right? I mean, how many times in your day are you like, oh, I got this? It's nice when it happens. So the data we're playing with, 3-category decision about whether or not you're going to apply to graduate school, no, maybe, and yes. That's the outcome. We're predicting it with characteristics of the undergraduates, their GPA, whether or not either of their parents has a grad degree, and whether they went to public or private undergrad. That's our model. So the first model, always, this is page 10, so we're in part 2 here. Always, always first, empty model. Why? See if it's predicting what? Say it louder. To see if it's giving you thresholds or intercepts. What's the difference? A -1, yes, but conceptually, it's whether the model is phrased in terms of predicting the red or predicting the green. Models that are phrased in thresholds are logically inconsistent. The intercept-like parameter gives you the logit of the lower category when all the predictors are 0, but then the slopes after that, they predict the green instead. So if you want to put it back together, it's -1 times the threshold at the beginning of the model plus all the slopes. I don't like that. That drives me nuts. So I want to know what my software is doing. The easiest way to do this is that if you run the empty model, we know that it should generate the predicted probabilities in the data set, like what actually happened. So you can figure out what your model parameters are in this case. This is why O-logit and ME-logit and Stata give you thresholds. So I'm switching to Go-logit for that reason, as well as the proportional odds thing that's coming later. Glimix, by default, gives you thresholds. I've overrode that with this descending option. So it's giving me intercepts. So the first logit output, this is O-logit from Stata. The bottom one is G-logit. Note the difference between the parameters, the -1. So we're going to do G-logit for the rest of the time. And here's the comparable stuff in SAS. These intercepts are directly giving me the logit of the higher category in each of my submodels. So just to remind you how the submodels are formed, I have the probability of saying something besides 0. So at least a maybe is the first model. The second model is moving from no and maybe to yes. Does that make sense? So it's easy to lose track of what this means in talking about it. But yeah, we're talking about the first one is just like no versus anything higher. The second one is no or maybe versus yes. So the logit of a yes, that's what this is telling me. It's -2. What does that mean? How likely is yes if my logit is -2? Not very likely. Much closer to the probability of 0 than the probability of 1. More specifically, only 10% of my sample said yes, I'm very likely to apply to graduate school. So a logit of -2.2 corresponds to a probability of 0.10. The other submodel, this is the logit of a maybe or a yes. So moving off of 0 to something higher than 0. That corresponds to a probability of 45%. So it's these two numbers put together. The logit of something higher than 0 gives a probability of 0.45. Just lumping them together. So the first model lumps together 0 and 1 and contrasts it with 2. The second model lumps together 1 and 2 and contrasts it with 0. So the order of these things is logically backwards, but I didn't see a way to control that. Okay, with me? All right. So add some predictors. This next model is what's known as proportional odds. It means that each of these submodels gets its own intercept, but all the slopes for the predictors are constrained to be the same. So it doesn't matter if I'm talking about the logit of moving off of 0 or the logit of saying yes. The effect of parent's degree and private versus public is the same. So I'm asking for a lot of stuff here. This is where I'm doing all of the coding myself. Since these are binary variables, they're just in their original 0-1 form. C dot means they're being treated as continuous. That's the default in SAS, so I don't have to do anything. I am writing out estimate statements. Isn't that a lot of code? Do you know why I had to do that? Because LS means is not available for cumulative logit models in SAS. They make you. The reason? This first column, it wants to know which submodel you're talking about. Stata is like, it's fine, I got this. Here's your margins. It's cool. Predict XB gives you the logit metric. The default, when you don't say anything, is in the probability metric. So I have 3 predictors in my model. 3 slopes for 3 different predictors. That results in significant prediction. We can go through these. So this first one, that's the logit of answering yes instead of something else for somebody with a GPA of 3 whose parents don't have a graduate degree and they went to public school. If we look at this slope right here, would someone like to try it? Put that number into a sentence. It's a slope. You know what to do with those. Don't think too hard. A slope is the change in y for a unit change in x, right? Right? That's still true. So for every unit change in x, for every additional point of GPA, so moving from a 2 to a 3 or a 3 to the 4, the probability, I'll say more, probability? That sound right? Does that number have anything to do with probability? Not directly. We're in logits. The logit of what? The higher category. It's either saying yes instead of something else, or moving off of 0. That number applies to both. So it's just the logit of the higher category. Goes up or down? Up. I'm not trying to trick you, I swear. By 0.6. So are people with higher GPAs more likely to apply to graduate school or less likely? More likely. If it's a positive number, it's more likely. If it's a negative number, it's less likely. How about this one? So for every 1 unit change in x, that in this case is Mhm.
There's a graduate degree.
Yep. For people whose parents have a graduate degree, the logit of whatever's higher goes up significantly by 1. So do children of graduate degree parents more likely to go or less likely? More likely, yeah. And this one, same story but not significant. And I would be willing to wager that in practice, like that's the end of the results section, like the end. Now this is dissatisfying to me. And you can probably guess why. It's dissatisfying to say the logit of the higher one without being any more specific, right? We made this big deal about making these submodels and giving them their own intercepts and their own interpretations, and now we're just gonna like let all of that go and talking about what predicts them. It's dissatisfying. If you look at the equation though, all we need to do is release the constraint that this is the same number. That beta 1 is the same between the equations, that beta 2 is the same, and that beta 3 is the same. We just have to figure out how to tell software to do that, and that's where the tricky part is. With me? Yeah. So I'm going to be not dissatisfied. I'm going to become satisfied to try and figure this out. And this is a plot showing the 12 different intercepts that I created, conditional and predictors, and the plot on the left shows this idea. The two submodels differ in intercepts only, but the relative differences as a function of the predictors are exactly the same. So let's fix it. I separated out the betas by adding on subscripts. I don't know if this is convention, but it seemed to make sense to me. So the second subscript is which submodel this goes with. This is another reason why I had to switch to go logit 2. Apparently there was a 1. Because ologit in Stata does not allow this. Likewise, in SAS, proclimix does not allow this. So I had to switch to logistic. Both of these are inherently single-level models. They cannot be extended to clustered data, multivariate data, longitudinal data, or anything like that. To do that, you have to write your own routines. But GoLogit anticipates that you want to be able to test this, and the only thing that's different is that there used to be a PL here that I took away. That's it. So the previous version of the Stata code, this thing, that's an option that says fit the proportional odds model. You take that off, it doesn't fit that model, it fits the one where all the slopes are different. The option gamma gives you an additional set of output that explicitly tests the difference between the slopes. Super useful. I am putting together a multivariate wall test for whether or not the set of slopes needs to be different between the submodels. Took me a while to figure out how to do that, but you refer to the submodel in brackets here. Analogously, in SAS, under proc logistic, there is an unequal slopes option that removes the proportional odds restriction. The last time I taught this material, that didn't exist. So I was happy to see that progress has been made. Yay, SAS programmers. And then here is their version of an estimate statement. They don't have estimate statements in proc logistic. They have this test statement thing instead, but it works analogously. So I have the name of the slope, an underscore, and then what it calls the submodels. And it pertains to what the outcome category is. So in this case, it's calling the submodel that predicts the yes, the vary, underscore, or to vary, because that's what it's called in the data set. That is the value label that goes with that number. And the second submodel value label that goes with that number is 1 eh. So this is a test. These three tests are given by gamma. Gamma does that for you. The last one, this overall joint test of all the slopes, is the one that I did right here, where it lumps them all together. Okay. With me? Good. Are you ready to see the exciting conclusion in these fake data? So go Logit, go Logit, go Logit. Here's my, it gives you likelihood ratio chi-squares, the degrees of freedom, 6, because there's now 6 slopes in the model. 3 slopes times 2 submodels. The first set of output, I have Stata output here. This is the slope for each submodel. Stata labels them differently than SAS does. This is the submodel of 0 versus something higher than 0. This is the submodel of 0, 1 versus 2. They put the intercept at the end, which is different than SAS, but otherwise we've got these two numbers here, for instance. Let's look at those. You see those? The first number is 0.59, the second number is 0.72. So the logit of moving off of 0 goes up by 0.59 for every point of GPA. The logit of moving from 0 or 1 up to 2 goes up by 0.72 for every unit of GPA. So these are on the same scale, right? GPA is the X, logits are the Y. Do those numbers look like they're the same? Well, look at the standard errors next to them. Do you think it's sufficient to eyeball these things and go, looks different? No. Reviewer 3 is not going to like that. So thank goodness we have the alternative parameterization. Gammas are deviations from proportionality. The difference between 0.59 and 0.72 is the 0.12. So the gamma 2 line is like the results of a LINCOM explicitly contrasting one slope against the other for the same predictor variable. It's not significant. So that means, yeah, the logit of the higher category in terms of the effect of GPA is sufficient. You don't have to split them out if you don't want to. Likewise, the effect of parent graduate degree, pretty much the same, very small difference. The effect of private school is very different. It's in a different direction. So the logit of going from no to something greater than no goes up by 0.23 if you went to private school. That is not significant. The logit of moving from 0 or 1 up to yes, I'm going to go actually goes down if you went to private school. But again, not significant. The difference between those two numbers, though, is very close to significant. So you can imagine a situation with a variable where the effects are completely different for different submodels, but if you try to smush them together into proportional odds, you would end up with something that doesn't make it. It doesn't describe either of them accurately. Now, do we need private school in the model? If we've addressed all of our research questions and we're trying to go for parsimony, do I need to keep this? Probably not. It's not significant in either submodel. It is, if we put them back together, it's not significant when you put them back together. That's a pretty good argument that it doesn't need to be there in terms of prediction. Question?
Can I ask a random question?
I love random questions.
So like in this case, if we really believe like we have two like 0 versus 1 and 2,
Mhm.
1 versus 2, usually believe they are kind of two different populations. And right now we just did model separate.
That's coming next, actually. So this is trying to capture some sort of tendency to be willing to apply, right? And so it's like 0 versus 1, 2 is like, are you just like even a little bit interested? At least a little bit? And then the other one is like, is it a solid yes or something less than solid? Like if you put conceptual labels, that's what you're asking. If you want to know what differentiates people who say maybe from no, and what differentiates people who say yes from maybe, that's not this model. This model does not tell you that.
Yeah, but, so when you test their slope difference, so
Do the differences?
yeah.
Okay.
But I feel like it doesn't make sense here. Because they are kind of from the same population.
Mm-hmm.
Right? So I think that they are kind of so which means I feel it kind of doesn't make sense to kind of test their slope difference.
I'm not sure that I follow your argument.
So what I'm trying to say, I feel like if you collect data as the whole population,
Mm-hmm. Collect data, whole population. I'm repeating for the Zoomers here.
so then you just need to, then it doesn't make sense to sort of test the difference between like a different level of reason.
You don't think having the separate slopes makes sense if
Yeah.
people are from the same population?
So if you really think they are different, then just do their model. I think it makes sense.
Yes, unless what you're trying to capture is an at least type of idea. At least type of idea inherently lumps answer choices together. If you are dissatisfied with that, then you will like the nominal model better. So it boils down to what you want to know. I think that it's conceptually okay to have different slopes for the different submodels. If you don't like that, if you don't feel it's useful, then don't fit it. I mean, it's people like to think of quant methods as like black and white, right? But it's filled with shades of gray, all kinds of shades of gray. And it's like at the end of the day, you need to convince 2 reviewers and an editor that to agree with your argument, right? Somewhere, and that's all. I can't tell you that it's right or wrong. I can just argue to say that I think it seems reasonable in this case. But if you don't have hypotheses that lend themselves to this at least kind of thing, then it's not useful. So same output for SAS, spits out each of the slopes. Here's the difference. And so it looks like we could have proportional odds for most of the model and not that one. So then I did just to show you in case you have a lot of things you're sorting through, there are automatic routines in both Stata and SAS. This auto will go through and figure out which of your slopes need to be different and then fit the resulting model. So you don't have to go through all the permutations yourself. This selection thing in SAS will do the same. So the model they came up with, because I put the constraint in that I wanted to keep all 3 predictors, is to say that GPA has the same slope, parent graduate degree has the same slope, and the slope for private is different across submodels because it was significantly different once you constrained the others. So the p-value went from 0.058 down to 0.033 once you constrained the other parameters to be equal. That's the idea of you don't want extra crap in your model because you lose power. That's this happening. Excuse me, unnecessary parameters. That's how you say crap. If you know what combination of things you want, then you can just specify it that way. So for instance, in GoLogit, you can just ask for which ones you want to be proportional odds or not. And then, as usual, you have the odds ratio as a separate thing. It'll either spit out logits or odds ratios, not both at the same time. And this I showed you last time. This is what I mean by write it yourself. So let's say that you want a non-proportional odds model, where the slopes are different across submodels, but you have multivariate data or cluster data or longitudinal data. Write it yourself. So NL mixed is a routine that allows you to specify your own likelihood and your own model. It has built-in distributions, but if those distributions don't match, then you can write it out yourself. Stata has something like this. I can't remember what it's called, but there is something like analogous to this. I've just never learned to use it. So the way that I figured out what all of these different commands were doing or not doing is to write my own model like this. So it's very empowering and necessary if you have multi-level data. Okay. Do you want to see nominal? If you don't like ordinal, here's nominal. This is where your outcome is essentially dummy coded. You are allowed to designate which category you want as your reference, and it compares each other category to that reference. So I decided to make 1 the reference because it's in the middle. So the first model is going to say, what is the logit of a 0 instead of a 1? The second model is going to say, what is the logit of a 2 instead of a 1? So maybe is my anchor point since it's in the middle. You can pick whatever you want. Now, there is no proportional odds. Everything is estimated separately always. So we have, we're back to M logit in Stata. We have base outcome 1 is the way to set your reference. Reference equals, and then I have the value label that goes with a 1 in my SAS data set. Bycat is an option you can throw on estimate statements to get the same prediction for both submodels. Note the change in the code otherwise right here. Glogit for generalized. Generalized is a terrible name, by the way. It means about 17 different things. It's baseline category logit or nominal. Though either of those I think are better descriptors. So Stata calls this multinomial logistic regression. It is a baseline category link with a multinomial distribution as opposed to a cumulative logit link with the multinomial distribution, which is what we just did. The trick to understanding what this information is to keep the conditioning in mind. So here's everything that we got on one line here. So the reference is 1, which is the category. The logit of answering no instead of maybe is 0.45. That's the intercept. That translates into a probability of 0.55. The logit of answering yes, very likely, instead of maybe, is minus 1.2, which translates into a probability of 0.1. So you have to figure out then how the model works based on what is logically possible. So in this case, the first submodel is the probability of a 0, or given that it's 0 or 1, what's the probability of a 0? So this 5 here is not the probability of a 0, even though you would think that's what it is. The probability of a 0 from the first submodel conditions on the possible values that are in the submodel, 0 or 1. So the probability of a 0 in that submodel is actually 0.611. because it's 0.55 over the 0.9 that's possible. Likewise, if you have either a 1 or a 2, that's 45% of the data. The 10% over the 45% is that one. Stata gives it to you this way instead. SAS gives it to you in terms of the numerator of the possible. So that threw me for a loop for a little while until I figured that out. So Stata does the conditioning for you, SAS does not. If we fit the same model that we've been talking about, now with separate slopes, here's what we get. So for instance, the slope for GPA, there is no effect of GPA on the transition between maybe and no, but it's non-significant, but it's in the direction you would expect. The higher your GPA, the less likely you are to say, actually it's backwards. The higher your GPA, the less likely you are to say no instead of 1. For the second one, the higher your GPA, the more likely you are to say yes instead of maybe.
So in the model, what you do is just put a reference equals.
Pick your reference, doesn't matter. I picked the one in the middle because I thought that made the most sense. Here's another instance. Does it matter if your parents have a graduate degree according to this set of findings? Sometimes, right? If you are deciding between maybe and no, you are less likely to say no if your parents have a graduate degree. That's the first one. If you are deciding between maybe and yes, you're more likely to say yes, but not significantly if your parents have a graduate degree. So is this better for you, Kofung? This makes you happier? I think of this as more useful, potentially. One of the things that these models assume is something called irrelevance of alternatives, something like that. It basically means that these slopes are invariant even if one of the options was not there. So like if I'm talking about no versus maybe, that set of coefficients should not change if I had different options besides those. This is one of those things. There's a way to test it. They talk about it in the Stata book that's on your reading list. I haven't seen that in practice, so I didn't throw that one in there. Same thing here. Looks like somewhat different results, although both in the same direction. So I have predicted logits and predicted probabilities. Here's all the predicted logits where that came from, and here's some words. So at the beginning of this whole thing, I said you already know how to do this, right? You know how to do binary outcomes. You know how to do this. The hardest part is figuring out what the hell a 0 means and what the hell a 1 means in this new binary categorization. Does it mean something versus everything else? Does it mean this versus that, but ignoring this other stuff? The latter is nominal, the former is ordinal. So trying to match your research question, what you want to know, to which model it is. In some types of models, even though it's ordinal, if what you want to know is decision theory, like what makes some people say yes instead of maybe, this model gives you that directly. If you want to predict what are the chances that you move off of 0 and you at least consider it, like when you're lumping together categories, that's the ordinal model instead, the cumulative logit. So, how are we doing? Yeah? We're good? Yay. So do you want to practice some of this stuff in homework? Would that be good? I think we're going to have to because we still haven't talked about counts. So we're out of time, but let me foreshadow where we're heading for the rest of the class. The days where you only have one choice for your distribution and it's always the right one are gone. They're gone. Just wave bye-bye. I know, it's sad. We're going to be talking about counts next, where there are a whole bunch of different choices for what the distribution should be. And you'll have to use model fit indices to figure out which one is better than others, as well as which one is the best in an absolute sense. But the converse of that, there's really only one length to choose from, and it's log. Because counts range from 0 to positive infinity. So taking the log of the count as the length function removes the lower boundary, because the log goes on forever and ever. But when you unlog it, when you exponentiate it, it stays between 0 and positive infinity. So the length will be log. It'll be a lot easier to not screw up in terms of there's no odds, right? There's only 2 scales. But the distribution part's going to be tricky. But you're up for the challenge, right? Right? Yeah. Okay. Questions? Yes, ma'am.
That's a software question. Did you have any problem downloading the Logistic?
I didn't. I had to search for it, and then it popped up a little help menu thing with a link, and I installed it that way. I don't know if there's a syntax command for it. I'm not that good with Stata to look it up, and so I just did it through the Windows.
It keeps me
That is good to know, because that was one of my things in the homework. I was worried about relying on GoLogit if not everybody could download it, because I wasn't sure within the virtual machine like what permissions you had to install new packages.
It didn't even let me, so I'm on remote desktop, it won't let me install anything. It just keeps saying it already exists. And even putting like comma replace override it won't let me.
If it already exists, then you should be able to use it.
It's saying, that's what I'm saying. It won't. And then I put GoLogit and it's like unrecognized command.
Oh, okay.
Okay, I'll troubleshoot it.
Yeah, but that's good to know. That means that you're probably going to be fitting proportional odds models and nominal models, because I want to make sure that everybody has the same things that are possible. So, yeah. Other questions? Okay, I was going to say have a good weekend, and then I remembered that it's Tuesday. So have a good Tuesday. Let me know if you need help with your homework. Office hours start now. Email is also acceptable. So, see you later.